Hello everybody. In today's tutorial, now that we learned how to install a physical pneumatic gripper on our Kuka using WorkVisual in the last tutorial, we're going to have a look at some simple programming in KUKAprc and Grasshopper on how we'll actually use digital outs to control the gripper, as well as multi-state tools in order to accurately simulate what the robot's actually going to be doing within the Rhino viewport. Normally I set up a brand new Rhino and Grasshopper document, but for this one, as we're focused on more advanced ideas, I'm going to jump into an already set up scene to match the video I produced, as well as just our pick and place locations. So for this one, let's jump straight in. We're going to grab our Kuka core component. I'm going to set up our simulation slider as always to be from 0 to 1 with a few decimal points. Temporary 6-axis just to make sure everything looks right. Set up our custom tool already. Can set tool. I've already done the tool calibration. 1.4, 0.25 and 109.78 along the z-axis. Confirm. Put in a mesh component. Right click, set one mesh, takes us to Rhino. We want the tool open state. If we select, it references our mesh geometry in our Grasshopper window. That goes into our core component. Now, for this tutorial, I'm using the Kuka KR8 Cybertech Nano R1620, which unfortunately is currently not included in the virtual robots. But KUKAprc does come with a custom robot component, which probably deserves a tutorial all of its own. For this one, we don't need to worry about it. And there's our KR8 with the extended axis too. Nice. Okay. So there's our initial setup. It moves home. That's all it does. Well, it moves to this component. So now that we've got our robot set up, we know that we want to pick up our cup that is positioned over here. So we want to move our gripper to the cup and grab it. So that would be PTP, because we're not holding the cup. We want to move in the most efficient way possible. We get rid of our 6-axis command, place that, run our simulation, and we can already see a bit of a problem. We can imagine that the cup is sitting on our little Kuka stand, and if the cup is here as the robot's moving over to it, it's going to swipe it straight off the table. We're going to have hot coffee everywhere, and we're going to be none too pleased. So what do we need? We need to do a manual offset. The default tool axis offset that you use a lot is always on the tool axis, but for this I want it to be down the ZX axis. So for that, I'm going to double click the canvas, grab a deconstruct plane component, take our pick plane. We're going to use our X factor, so we'll grab amplitude, which takes an existing vector. We're using the X as dictated by our pick plane. Amplitude, we're going to take 150. That's saying move down this vector 150 millimeters. I'm going to double click and grab a move component. The vector is our translation vector, and the geometry is our pick plane. So we're moving our pick plane down 150 down the x-axis, but we can see a problem already where we put it into our PTP and we get a critical error because it's out of reach. Unreachable position. So the 1620 is an incredibly long, slender Kuka, but unfortunately it's not that long. So we can simply right click our T, x times -1 to times whatever's going into T, times it by -1. And now we can see that it should work perfectly. So we just We might even just move that back a bit further, so increase the 150, a bit back, and then the gripper stays clear of our stand at all times. Okay, so this is pretty basic. This is stuff we've done quite a few times on this channel. Cool, looking good. So now we want to do a linear movement into our cup. So we know the cup's sitting at this position. So we're going to grab a linear movement component, and we'll take our pick, simply put that into our plane, and we'll add that under our PTP by holding Shift. You can run the simulation and see, perfect. So it comes in and then it goes back to home because we haven't given it any more commands after that. Okay, perfect. So this is the position. After this position, we want it to close the gripper. So that means we're going to grab a component, we're going to grab our digital output component, which tells our Kuka to send the signal to whatever digital out we put here. So we're going to double click, put in a new panel, and from our last tutorial where I taught you how to set up a pneumatic gripper, we know that digital out 1 is set to close. So we're going to set it to close. We need to say what we're saying. It defaults to false. We'll grab a new toggle. We're going to say, no, we want you to say true to close. And then finally, we've got this great little input here called tool. And that's for a tool like a gripper, it can have multiple states. So we can say state 1. We don't need, we'll say state 1. So, at the moment we only have one state. So if we add this to our commands, we can see that, oh, what have we got? Might have an error because we don't have any geometry. See, okay. So we go, we're in the open position. So we need to tell KUKAprc to simulate the multiple states of the call. So under 03 virtual tool, we have a fantastic component, multi-state tool. We can take our geometry, double it. We put open as first and closed as second. But that's the same geometry. So all we need to do is we'll go back into Rhino, show our thing, temporarily hide our grasshopper geometry. Closed, we can see that we've got the gripper with the glass, the cup. So if we right click our new mesh, set one mesh, now we can see, don't know how, let's go this. That just gives us our code. But I know that we've got 2 coming into this list. So this is in index 0, which is open. And this is in index 1, which is closed. So when we turn digital out to true, we are telling the gripper to close. Quickly hide that layer again. Preview our grasshopper geometry. So now when we simulate, we should ideally, we've got to change our tool index to say when that is true, we are closed. Now we're returning home. So obviously this is not what we want, but we start with our tool open. We come down, we move in linear, close onto the cup. It's going very fast. We know that it will take a split second for our pneumatic gripper to close. So we'll go to utilities. We can say wait. And we're going to wait for 0.3 seconds. Let's just tidy this up. We'll just move our core across. What we're going to do is we're going to grab our double click canvas and grab a merge component. We'll just put in our commands. Now I can better visualize what we're doing now. All this is doing is merging the items in order. So we come down, close, wait for 0.3 of a second. Now, what we're going to do is we're going to put this one here. We're going to say that 1 is now false. We're going to change that to keep those closed. But this, if 1 remains true, and we try and turn on digital 2 to open the gripper because it's pneumatic, nothing will happen. So we just have to remember to turn off our digital out. And now we need to move it to our place position. So if we say we want to move it linear, because if we do PTP, the robot's going to move as efficiently as possible and it won't worry which way this is orientated, meaning that we could end up with coffee spilled all over us. So what we're going to do is we're going to grab another linear. Let's have a look at where this is. We've got our place position sitting right next to our laptop so that we don't have to get up and get our own coffee. And if we simply put that in, we can see that we've got another little bit of an issue here, where if we just zoom in, we can see that the robot is going to drag the coffee over the table because it doesn't actually know that the table's there. This is really easy to fix. We already have the position. We've got the geometry here. We can simply zoom in on our merge component. After we've grabbed it and turned it off, we simply zoom in on our merge component. It gives us an insert parameter. We're going to say we want to move back to this in a linear motion. And this takes over 6. 6, that's you. Let's have a look. Come over, move in linear, close, grab our cup, move back. What have I missed here? What have I got to? I've used the wrong component. So then linear here, which we can actually we can put that in there and get rid of that. So we can recycle components when they're in order. Because how this happens is how it's going to be interpreted by our analysis. So if we want to have a quick look, we can click on KUKAprc settings. Under the Advanced tab, we can say Output Analysis. And we can also code output KRL, the analyst component. This, depending on the script you're making, this will slow down. You can see that it's already adding a couple milliseconds. Under Utilities, we've got the KUKAprc analysis component. Simply analysis to analysis. Put a panel into our KRL. We've been working out. If we have a look, what we want is, actually what we will do is we'll go into our KUKAprc settings. Because we're using digital outputs, we're going to check to reset digital analog outputs at the start. Because like I've already mentioned, if when using a pneumatic gripper, if one of them is already set to true and the other one tries to set to true, it won't change its location because the air will already be in there. So now we can see our KRL has already updated. Initially, we set all of our outputs to false and 0 for analog. And then we have our PTP. We have our linear. To pick up our cup, we say that we want digital out to be true wait for 0.3 seconds, turn off digital out. That won't release it, but it will turn off the digital out. Then a linear movement back to here, and then linear over to the table. But then we can see, unfortunately I didn't model my table. I just go back into KUKAprc settings, advanced, and turn off our output. Okay. We can see that if I had my laptop sitting here, the robot's going to pass straight through. So we're going to repeat what we did earlier. We're going to deconstruct this plane as well. Deconstruct the plane. I'm going to use another amplitude. I'm going to take our X vector here and say 250 this time. Move some of this over. We're going to move our place by this. We have the problem again where it's going in the positive. So just quickly x times -1. So now we want, what have we got here? We got our pick in first. And then we want to come down to our place. And then we want to put in our final place. And then we need to do our open our gripper. So we can copy our digital here, simply move it down. Now we're saying we want 2 to turn on, 2 to turn off, and our tool reverts back to index 0, which updates our multi-tool state to be 0, which is our top index. Add them to our merge. And then finally, I think we have one more issue. No problems here. So we move over, we move in linear, we grab the cup. No, I've messed up my order here somewhere. Okay, we grab the cup and then we need to move back. So it's this component. Let's just, so we're here. We need to move here first. And then our moved place. And then our final place. Okay, now let's have a look. So come over, close our gripper, move down to our table, move forward, release, and we're doing the same thing where we're going to take our cup with us. So now instead of just moving home, we're just going to say come back. We can simply list item really quick. I don't really recommend doing this because this makes your code look really unclean. And if someone needs to change it in the future, I don't really recommend it. But if we just say take the last item there, it should. No, it's not the last, is it? What have we got? There's 2. The second last, which is also the middle, but if we had a long one, we just want it to move back to the offset position. So back, so drop the cup, move back, and back to home. Okay guys, so that is a really quick introduction to how to set up multi-state tools. Really handy for when you're simulating tools that are going to change shape to make sure that you're going to run something safe, as well as working with digital outputs in KUKAprc. Hopefully this is a good introductory. I might do a follow-up to this of a bit more advanced where we do multiple pick and places. But until then, hopefully this is enough to get you started.